This is basically an energy converter. So, and the major point behind these backup power systems is always you have to first look on the electrical integration, because a fuel cell system or a fuel cell for itself is, I always say, produces unregulated voltage. So you always
going up and down. Right?
Yes. So and there you have to see how you couple this with the grid, and also as a fuel cell system also always needs some power to start up.
Okay.
You couple it in backup power systems with a battery.
Okay, so what we see here on the diagram is essentially the consumer, the load side, and this is the grid. And then the backup power goes in here, in between all that.
Yes, so basically what you see here, you see the blue box that I brought with me.
Yeah, okay, that will be that one, yeah.
For example.
Yes.
And as I said, the fuel cell is producing a DC voltage output.
Direct current, yeah.
And the DC voltage output of the fuel cell doesn't always match with the battery. You have to couple this with the DC-DC converter. This is an essential part where you bring them together.
All right. And then so you have one voltage here on this. So this could be whatever. It could be 240 volt AC. Yeah. Okay. And then you have a converter here. And what this battery could be any size as well.
Well, basically it is, when you look at how you set up a backup power fuel cell system, you always have to look at the load. You have to say, okay, what is the load? What power level does it need? And if it starts, it always has a peak. So basically what you try not to do is have the fuel cell supply the peak power. So for this, the battery jumps in.
Yes.
Cuts the peak power more or less,
yes.
and also brings the energy for starting up the fuel cell system, because we have to consider that the grid is gone.
Yes. Well, I mean, I know several, let me say, kind of power systems, and they all need some form of energy. Even diesel generators need a battery to start up. So take us a little bit further. How is this all made up?
So basically now when we have looked at the basic sketch of the power electronics, of the electronic side, then what is missing actually for a fuel cell system, as you just mentioned, diesel, we have to supply a fuel cell with some media. A fuel cell, what you bring in is air, surrounding air, and of course hydrogen. And hydrogen is the energy source. So if you talk about what is the backup power, the backup time of the load, you have to consider how long it runs. And based on the bridging time, what they call it, you bring the hydrogen as the energy source. Both of these medias you bring into the fuel cell. This is basically an energy converter. It produces heat, electricity, and pure water, and has some exhaust. And we bring out the exhaust, air, water, and maybe some purchase through this line. Also, as I said, a fuel cell is producing beside electrical power some heat.
Yes.
The value is basically 50-50, I would say. So we need also a cooling unit.
For that, okay. Understood. So essentially now we're substituting the grid as an energy source with hydrogen as an energy source for this load.
So when you look how this normally runs, so in the beginning, let's say the grid is there. If the grid falls away, then the battery takes over and immediately bridges the gap of the grid to supply the load, and also supplies the necessary power to the fuel cell to start up.
Okay, and then that starts up.
As soon as the fuel cell is there and can supply the power, the fuel cell completely takes over, and then the complete energy for the load and the power for the load is supplied through hydrogen and fuel cell.
All right.